Okay, so I told you to calculate the variance before starting this video. Please finish your algebra. So remember, the variance is the average squared deviations. So like we already calculated the mean, that was the first step. And the second step is to calculate the deviation, subtracting the mean from this outcome and from each outcome, 1 or 0. So once this successes, deviation is plus 0.8 and 0 has a deviation of minus 0.2 after subtracting the mean. And then square them, so you get these numbers. And then, so these are square deviations which has the same probability distribution. So calculate the average of these guys. So multiply the probability weighted square deviation is 0.2 times 0.64, right? Like this. And multiply probability to this guy like this and sum them. So the variance is 0.16. That is the variance of this binary variable, the online quiz, the randomness in randomly choosing an answer to your online quiz. So now I'm going to study what this means, where this number is coming from. Right? Like, so to study that, we can generalize that algebra to a alphabet unknown p. Suppose that just the probability is unknown, but as known as p, and then like the mean can be calculated in the same way, outcome times probability p, outcome times probability 0. So the mean is p. As I told you in the previous video, the mean is always the same as the success probability, right? So the mean is p, so we are going to interpret this as the probability of success. Okay, up to this point, it's clear. Now, what about the variance? We just do the same algebra with unknown p. Not a problem, like, because the mean was p, the deviation would be 1 minus p or 0 minus p, and you square that, and in the same way we calculate the probability weighted squared deviation, like this, and sum these two. That is the variance. This summation, it may look a little tedious, but it's not that difficult. Just expand the squares, and then you get things. The third term, third order, canceled out, and in the end you get minus p squared plus p, which is p times 1 minus p. Okay, so like as you can see, the variance is expressed in terms of the p. As I said earlier, one parameter p is enough to explain anything about this binary variable. So also the variance depends only on the unknown parameter p. So if you know p, then you can calculate the variance. In particular, I am going to interpret this as probability of success times probability of failure, right? So the variance of a binary random variable is success probability times failure probability, right? That is how we formulate the variance of a binary variable. It is pretty simple. And so earlier we went through all these algebra to obtain 0.16, but actually if you know the probabilities, then shortcut is just to multiply those probabilities. It is just a special property for binary random variable, right? I know, okay? So again, the point is that we use only one parameter to explain probability, mean, variance, and everything. So that's the point of doing this modeling, right? So then, what is the intuition behind it? There is an intuition from this formula, right? So now think about this. When you have a coin flip, like it's 50-50. So tails 50%, heads 50%. That is the most chaotic thing, right? you cannot predict what is coming, right? Because no matter what you choose, anyhow, you are going to lose with 50%. However, now suppose think about a kind of unfair coin whose probability of heads is 99%. If you know that, that coin is very predictable, right? Like same thing can happen if the failure probability was 99%, right? And the point is the probability is related to the predictability, and when it is the most unpredictable is when the probability equals 50%. So the variance is maximized. The variance, the probability, the measure of volatility, measure of variability, is maximized when the probability is 50%. In that case, if you try different numbers, so the variance is biggest when the probability is 50%. But as I said, if the probability deviates from 50%, now you can predict better, right? Success, the probability goes to zero. As the success probability goes to zero, then you can predict that, oh, the outcome will be failure, right? So the variance will be smaller because it is predictable. And vice versa. If the probability goes to the probability of success goes to 100%, it is also predictable. You can predict that it will be a success. So the variance will go down, right? So variance in some sense is related to the predictability. And in your online quiz, you are going to choose a wrong answer with 80%. So that's why the online quiz works, right? Even if you don't know anything but just randomly choose all the questions, you are likely to choose a wrong answer. So that's why you have to study, right? So it's predictable, reasonably predictable than true-false questions, okay? Okay, so far was just everything about binary random variable. Was pretty simple, and we are going to extend the binary random variable model to a binomial distribution model, right? So in the binary random variable, we considered only one experiment, 0 or 1, just one question from the online homework, online quiz. But what we actually get is a set of 10 questions. One quiz has 10 questions, and what you are interested is the grade out of 10 questions. So we will define a new random variable called a binomial random variable, which is the number of successes in multiple experiments. Exactly the online quiz, right? So binary is about one question, but binomial is a set of multiple questions. And then in this case, the outcome is not just 1 or 0. So for example, if you throw a coin 100 times, for example, then the number of heads can be from any number, like can be an integer from 0 to 100. If you throw a coin 100 times, in an extremely unlucky case, you are going to get 0 heads. And the other extreme, you are going to get 100 zeros, 100 heads, right? So the outcome, the number of heads you can get is from 0 to 100. Okay? So then we will make more assumptions to explain the randomness in this distribution. First, I will assume that you repeat n number of experiments. You do n trials of a binary experiment. And each experiment, I already said this, but it means that each trial has only 2 possible outcomes, right? So 2 possible outcomes on all the trials, like heads or tails, or choose a correct answer or not, things like that. And third assumption is that the probability of success is the same for all trials. basically you are repeating the same trial, same experiment repeatedly. If the probability changes, that means they are different binary distributions, so our assumption fails. Finally, it is very important, all the trials are statistically independent, right? So in coin trial example, you are like the first coin throw and the second coin throw should be independent. The first outcome has nothing to do with the second outcome, unlikely to happen. In online quiz, I'll assume the first question and the second question are independent because you are randomly choosing all the questions, right? So that's independence assumption. And under these four assumptions, we say y follows the binomial distribution with parameter n and p. Now we need two parameters. Here you have to specify how many times you repeat it and what is the probability of success in each of them, right? So it is simple extension of binary distribution, but pretty different, of course, very different and very complicated. So anyhow, the point is now we need two parameters. Still, it is pretty strong because, so now back to the online quiz example, we started from, like say, suppose that question ith question, you get xi point. So x is the outcome from question I, right? And it is 1 if you choose a correct answer, it is 0 if you choose a wrong answer. And we learned its probability is 0.2. And then what we are interested in is the sum of 10 grades, sum of points from 10 questions. This is your like quiz grade. And we define y as the binomial distribution, binomial random variable with parameter 10 and 0.2. And think about the online quiz. The possible outcomes are 0. You may get 0 point possible. And also you can get 10 points. That is also possible, right? So there are 11 possible outcomes because it's from 0 to 10. But the main point here is we are going to describe 11 possible outcomes or 11 probabilities. But we only need two parameters. So two parameters can describe 11 probabilities. It's a huge savings, right? Huge savings. So that's why we study this theory. It simplifies your observations and like you can make everything much simpler. And think about this. Okay, so now if you think about coin flip, 100 coin flips, there are more than 100, like 100 possible probabilities. Still, you need two parameters. So you don't need to calculate 100, but just two parameters are enough to calculate the probabilities. Okay, that's why we are learning statistical models. And now, another running example is reservation. So you can think about reservation for at a restaurant or for a flight or a hotel, whatever. So suppose that there are 10 reservations made for a flight, right? And I simplify that the probability of cancellation is only 10%, like actually 10%, which is maybe greater than the real probability. But suppose it is 10% for each reservation. And I additionally assume that cancellation is independent across reservations. So even if the first reservation is canceled, it does not affect the second reservations, the other reservations. So they are randomly, like independently happening. So, and I will, under these assumptions, I am going to denote xi to be the cancellation status of reservation I. So there are 10 reservations, 10 tickets. So ticket number I can be canceled or not. So I am going to denote cancellation as 1. So cancellation is success in this notation. As I said, success doesn't mean it's good. So I just call it success because that's the unified framework. So cancellation is denoted as 1. Non-canceled tickets is denoted as 0. So if it is not canceled, that means the ticket holders is going to travel. So then y is the total number of cancellations that follows the binomial distribution, n times p, n comma p. Sorry. So basically the same structure as like coin flip and online quiz example. Okay. So I am going to use this example to explain a lot of things. Okay, then think about this. In the same setup, it's a brain teaser. What is the probability that exactly 2 reservations are canceled? I am curious the probability that 8 ticket holders come to the airport and board, but 2 reservations are canceled. What is the probability? Of course, at this point, you cannot calculate that. I'm just asking you, just guess what would be the probability. So probability of 1 cancellation is 10%, and I assume that most of you think it's 20%. Or if you're a little more advanced, like say, cancellation, one cancellation is 10%. If there are 2 cancellations, maybe you can multiply 10% twice. 0.1 times 0.1 would be 1%. But actually, the answer is 19.37%. It's a rounded number. So I gave you this example to show that this is not as easy as it looks. So the totally weird number comes up, and to learn this, our main purpose of this, main objective of this course is to understand why you get 19%. So there is no like, so only you get like 10% too. How can you combine these 3 numbers given in the question to get 19%? I'm going to explain that. And to see that, we have to go through a lot of steps, right? So I will spend a lot of time to explain why we get this number. So I think it takes like 2 or 3 videos, but I will try my best to explain the intuition behind it. It'll be fun, and so I will do that. I will start that process in the next video. So I really look forward to explaining this to you. Okay, see you there. Bye.